Alright, we're going to do another example of this. Easy trigonometry. Remember, nothing new. Just a little bit of grade 9 stuff and a little bit of thinking. Okay? Let's see. Find the exact value of sine cos tan of positive 3/4 pi. Okay, here's our circle again. Okay, so 1 pi is 4 over 4 here, 4 over 4 pi here, and 8 over 4 pi here. So that's 2 pi. Well, we're dividing it into quarters, so there's, we'll call it 1/4 pi, 2/4 pi. This is always half pi and 3/4 pi. 3/4, sorry. Never mind what I just said. 3/4 pi. This will be 5/4 pi. 6/4 pi. Okay. 2/4 pi and 6/4 pi are always going to be there. Maybe in different fractions, but they'll always be that value. And this here is 7/4 pi. Okay, piece of cake. So what are we doing? Positive 3/4 pi. So let's move. Positive means counterclockwise. So we're going here. Okay, so now we're going to create our reference angle, which is going to drop us down to the x-axis, and there we go. Now I drew from there, so what I've done here is that point is, this is the point P on the unit circle where that angle arm intersects the unit circle here. So what do we have here? If we divided, okay, remember, pi is 180 degrees, right? So if we divide it into pi quarters, okay, well, divide by 4, that means that pi quarters is 45 degrees. That means that every section here is 45 degrees. There's 45, there's 45, there's 45, and there's 45, okay? What that means then is that we're dealing with a triangle that has, it's 90 here, this here is 45, okay? And if the total degrees are 180, that means that this side is also 45 degrees. So this is another special case of triangle where we have the same angle here. What that means is that this side and this side are the same, okay? Now, let's just look at this here. So I've extracted this triangle onto our drawing here, okay? What we're going to do is figure out, we want to find the ratios, so that means we need to find, you know, our A, B, and C. Once we know our sides, then we can know our ratios, piece of cake. So, I say that a lot, don't I? Anyway, so let's figure out what the sides are. We know right off the bat, because we're dealing with a unit circle that our radius is always 1. Doesn't matter where it's drawn, so that's 1. And because we have this very special case of triangle, we know that we don't have to calculate sine to figure out the side. We just know that these sides are the same. So why don't, if we say A equals B, why don't I just, I'm going to rename them both as A and see what happens, okay? And now, to get the sides of the Pythagorean triangle with a 90 degree triangle, we use the Pythagorean theorem, which was this. Okay, but I already said that B is the same as A, so what I can do is just go like this, right? We know that, okay, so what we have here, we have 2A squared, and on this side, C is 1, so we'll just put that there. 1 squared is just 1, so that's good the way it is. Okay, so I want to isolate A and see what it is. Well, why don't I'll divide by 2 first, because they're married together with a time sign. Okay, so that'll cancel, and I get A squared equals 1 over 2. Not good enough. I want A by itself, so I'll square root both sides, and that cancels out to A. This will be root 1 over root 2. Now here's something we never want to do is leave the denominator with the root sign in it. So what I'm going to do is, it's called rationalizing the denominator, okay? What I'm going to do is multiply, like root 2 times root 2 is the number 2 by itself. So what I'm going to do is I'll just multiply the bottom by root 2 and the top by root 2. That way I'm not changing the value of the fraction. And, well, okay, before I go there, root 1, the square root of 1 is just 1, so I'm going to just clean it up a little bit and just write the number 1. And now what do I have? I have A equals 1 times root 2, so root 2, and bottom I have root 2 times 2, which is just 2. Okay, so this is what the leg of my triangle is. But conveniently, both are the same. So now I have this as my distance there, and this is my distance up and down. So now that we have all, I dropped my chalk brush. Now that we have all the sides of the triangle, we are able to get our ratios, the sine, cos, and tan. So let's look at this here. We're talking in this is our theta here, this angle that's attached to this here, so we're going to talk about this 45-degree angle here. So sine of theta, okay, that's this guy right here, okay. Well, that's opposite over hypotenuse. That's root 2 over 2 divided by 1. Smart lazy math people, we don't have to say that it's divided by 1. This is sine of theta. Cosine of theta equals adjacent over hypotenuse. Well, adjacent is also this over that. So, I mean, sine was this over that, adjacent is this over that. So it'll be the same thing. Root 2 over 2 divided by 1. But we're smart, we don't have to write it in. And then tan of theta will be opposite over adjacent, which is the same as root 2 over 2 divided by root 2 over 2. Well, I don't like showing my fractions like this. I'll say times by the reciprocal, just so I can see it better. Keep it to what we know, grade 8 math. So, well, look, we can cancel this out. 2 over 2 is 1. Root 2 over root 2 cancel out to 1. So tan of this equals, of this particular thing equals 1. Okay, so what are our ratios? Sine, cos, and tan. Okay, now again, because these are radicals and we didn't round to decimals, we didn't use a calculator to mess with decimals, we know that these are precise measurements. Okay, and that's what we want. Okay, any questions? Send me an email.